Okay, so 7.2, volume, the disk method. So last section we had a graph, and we had this was graph 1. I need another color. And this was graph 2. And we probably went from here to here, and we found our volume, and it was solid, and the world was all good, right? But what if we don't have a shape like that? In the book, they give some nice examples of different kinds of shapes. Like this funnel would have an empty space the whole way, correct?
Yes.
So, like this one here, if I cut it into a piece like this and then rotated it, could I get it? Yes. So we're going to have the disk method. And the disk method obviously is a little bit different. Okay, so I'm just going to jump to it. And well, I'll show you their pictures before we go on. So the disk method breaks this up because it comes down and gets smaller. So we have a change. We have this disk and this and this and this and this and this. So we have the sum, which changes into an integral, right? So that's the process of getting to where we are. So we take this nice smooth shape, and then we get these disks. But if we make these disks narrower and narrower and narrower and narrower, I'm going to get a better approximation of my volume. So that's why we do the intervals. So the disk method is we have a horizontal disk, and that means it's rotated around the horizontal axis. So I hate to say the x-axis, but the x-axis is one horizontal axis, correct?
Yes.
So I'm just going to put horizontal axis of revolution. Volume equals pi, because we have a circle, yes?
Mm-hmm.
Pi. Integral from A to B of R of X squared dx
Does the R stand for?
Yes, it stands for the radius of the disk. Okay, so R of X yeah, we have the radius of the disk, and we'll do things with that. I don't want to go further into that until I see some examples. So vertical axis of revolution, and one vertical axis would be the y-axis, correct?
Yeah.
Okay. Is V equals pi from C to D. And I'll give you a picture on both of these. I think that might be helpful, huh? Of R of Y, not X. Why is it Y this time?
Because it's on the vertical axis.
Squared dy. So for your X, an example of that, I'm not gonna put X axis, I'm just gonna put, like, here's my axis of rotation, and we signify that with a little arrow. See how that's rotating around that axis of this shape.
Yeah.
So this is A, this is B. And so from here to here would be my R of X. That radius of revolution.
Can you explain that?
Well, if this is my disk here, my piece, see that?
Yeah.
So then this from here to here would be my radius. Or here, I'll put it over here. So from here to here would be your R of X. It's your radius of revolution.
Oh, okay.
And that's why it's a capital R. Okay, so then this here, our vertical, would be rotated this way. And so my discs would be cut this way, wouldn't they?
Yes.
So from here to here would be my R of X.
Shouldn't it be R of Y?
I mean R of Y, yes, it should be. R of Y. And this would be my D and my C. That looks like a G, doesn't it? Do the pictures help a little?
Yeah.
You're done? Okay. So the first, we are going to start first with shapes that don't have holes. Okay? We don't have a... I should have been clear. We have disc method and we have washer method. You guys ever seen a washer?
Yeah.
It has a hole, right?
Yes.
So disc are solid, but they're in that still that same shape. We're rotating this. Okay, so find the volume of this solid formed by f of x equals the square root of the sine of x and the x-axis from 0 is less than equal to x, which is less than equal to pi, about the x-axis. Okay, so the first x-axis is this equation and the x-axis form your shape. The next one is where we're rotating it about. So we always want to get a picture. So if you don't know what something looks like, how can you find out?
Put it into your calculator.
You can put it into our calculator. So I have the square root of the sine of x. And remember when we have sine, cosine, tangent, we need to hit zoom trig so we get the right picture.
Okay.
And that's what it should look like. Okay. So it's going to keep going because we know that sine is cyclical, correct?
Right.
And it keeps going. We are only interested in from where to where? From 0 to pi. So 0 to pi is right here. And if you want to check, you can hit trace and pi is like 3.14, right?
Right. Well, we know that 0 would be at 0. Right? So we could just eyeball that.
And the pi is here. See that?
Yes.
Okay. So, because it has 180, which would be pi. So, we're going to draw ourselves a picture all the time. Because it is much easier to do these problems when you can visually see them. And in my calculator, it looked like they were circles, but they're more elongated. Really not that big a deal, but they are more elongated. Okay, and we're rotating it about what?
The x-axis.
So just draw yourself a little. So when I'm doing this, the shape comes down here. Correct? And we rotate it in and we have this solid sphere we want the volume of. So the difference between what we were doing before, we weren't rotating it, were we? We just had this flat shape. So r of x, this radius here, is determined by our function, isn't it? So we are going to have v equals pi from a to b of r of x squared dx. So we have pi, correct?
Mm-hmm.
Oh, what's our a?
0.
0. And what's our b?
1.
What's our b?
Pi.
Pi. So 0 to pi. And our r of x is our function. So the square root of sine of x. And then what are we doing to that function? Squaring it. Dx. So when I square a square root, I get what's inside, don't I?
Yes.
So I have pi from 0 to pi of the sine of x dx. So what is the integral of sine?
Cosine.
Negative cosine? Negative cosine? Because the derivative of cosine is negative sine. Oops. From what to what?
0 to 1. Or 0 to pi.
0 to pi. So this pi is just sticking out here. So I have negative cosine of pi minus negative cosine of 0. Is that right? That's how I do integrals, isn't it? Definite integrals.
Yeah.
So the cosine at pi is? Did you say 1?
No, I said hold on.
Oh.
I'm not done writing.
Sorry.
Okay.
So the cosine at pi is negative 1?
Um,
So negative 1 minus negative, what is the cosine at 0?
0, no 1.
1. So I basically get 1 plus 1, don't I?
Yeah.
Which is
2.
2. So my volume is 2 pi. And they don't give me any units, but it would be units what? Cubed?
Yeah.
Okay.
Yep, because volume.
If you want to put units cubed, just so you remember, but they don't give me any units. Okay, now the upper graph, I guess I didn't, the upper graph on here is the square root of sine, correct? Of these two. And the lower is 0.
Yep.
So when we apply all this, it really doesn't come into play when we have that x-axis. But when we don't have the x-axis, we have some things we have to do. Now, I don't know if you guys have ever noticed, but I have people all the time that ask me about this little shape I have right here. Right here. Which is this. Several years ago, we were doing these, and I had a student say, I want to know if this equation really gives me this, Mrs. Mick. So this problem right here, he took all of it and he put it in, and he got the same shape they have there, because he didn't quite believe that. Isn't that kind of cool? That's cool. He made it for me, my 3D printer. I'm like, you need to give me one of those for everything. So our next one is not the x-axis, not an axis. So we have f of x equals 2 minus x squared, and g of x equals 1. So I gave you two equations, didn't I? Okay. And we will be revolving this region about y equals 1. So this shape here, you should know that's a parabola that opens down, and the vertex has been moved up too.
Yes.
Correct? Yes. Okay, so 1, 2. So the vertex has been moved up here to 2. So it looks like this. Probably should have drawn this over here. Yes? Okay. G of x, so that's y equals 1. So that would be a horizontal line at 1, would it not?
Right.
Yes? So g of x would be here. Did the colors help?
Yeah.
Now, so if I want the region bound by these two, then we're just right here, aren't we? This stuff. So I'm going to take this, but I'm revolving it about what? The y equals 1.
Yep.
So it's going, this y equals 1 and g of x equals 1. That's the same line, isn't it?
Mm-hmm.
So we're going to take this and just revolve it. Now, mine doesn't look as neat as the picture. Here's their picture. And they're zoomed in and all sorts of stuff. But it gives me an idea, and I usually write my thing here so I can keep my brain straight. So now I have to find some differences between two things, don't I?
Yeah.
Like I know when I find just this volume, don't I have to take this integral minus this integral?
Mm-hmm.
Because that's what we learned in 7.1, isn't it? So in this case, r of x, the top function is what? F of x. And the bottom is what?
G of x.
G of x. So this is going to be my, because that's between it, isn't it? That's how I find the between. So what is f of x?
2 minus x squared.
So I have 2 minus x squared minus g of x, which is
1.
1. So my r of x is going to be what?
1 minus x squared.
1 minus x squared. So when I move it off that x-axis, does it add that extra bit in there? Yes?
Yeah.
Okay. So now, we got to find where they intersect, don't we? How do we find where they intersect? How do we find where they intersected?
On the f?
You have to find where they're equal, don't you?
Yeah.
Yes?
Yeah.
So, we're going to find a and b. So 2 minus x squared equals 1. We need to know where that happens. It didn't tell me where my AB was this time, did it? So since I have x squared, how about I move everything over this direction? Sound good? So I have positive. So I have x squared minus 1, don't I?
Yeah.
Equals 0. So that would be x minus 1 and x plus 1. So x equals positive negative 1. So my A, B are, this is negative 1 over here. And this is, actually I shouldn't have put it right there. Let me erase that because that's deceiving. My brain is seeing it right, your brain is not.
What happened to your 2?
I moved everything over. So I took, maybe,
Okay.
I added my x squared and subtracted my 2. Okay, so this point of intersection right here is negative 1. And this point of intersection is what? 1. Is that better? My brain knew what I was doing, but I wasn't drawing it correctly. Okay, so now I can find the volume. So we have pi of the integral from a to b of r of x squared dx, correct? So what's a to b?
Negative 1 and 1.
Negative 1 to 1. And we found that by just putting them equal to each other, like you had to do in 7-1. Didn't? What's wrong, Shelby?
I'm not sure. I thought I was getting it, and then I just died.
Okay.
It'll
Do you get how we got negative 1 to 1?
not particularly.
Okay. So on the last example, they told me it was from 0 to pi.
Yes.
They told me that.
Yes.
This one just says you're revolving these two about y equals 1. So you have to find where they're equal, where they intersect. So I just took 2 minus x squared equals 1. I moved everything over to the right, so I added x squared and subtracted 2. I got x squared minus 1, which is the difference of squares, so x plus 1, x minus 1. So that's where they intersect.
Okay.
You good now?
Yeah,
Do you understand how we found r of x?
F of x minus g of x.
Yep. And I just plugged in f of x, plugged in g of x, and combined like terms. Okay. So we're plugging in here. So pi a to b is negative 1 to 1. And r of x is now what?
It's 1 minus x squared.
So I have 1 minus x squared, quantity squared, dx. So we need to multiply this out correctly. Yes. Because this is 1 minus x squared times what? 1 minus x squared.
Yeah.
So we FOIL that out. And you should get 1 minus 2x squared plus x to the fourth, if you do that correctly. Dx. And then what's the derivative of 1? Can I move all this up?
1x. I mean, just
Yeah,
x.
just x. And then we'd have what, minus 2/3 y cubed? Y, how about x cubed? And then what, plus 1/5? You guys check my work. Did I do that right? Add 1, multiply by the reciprocal. So 2 plus 1 is what?
Oh, you just added.
Yep, because we're integrating. 2 plus 1 is 3, so it'd be 2/3 x cubed. 4 plus 1 is 5, so 1/5 x to the 5th. Did you guys forget how to integrate?
Yeah.
Over the weekend, it just turned out. Okay, so now I have to do the top minus the bottom, correct?
Yes.
Keep the pi out. Okay, so I have 1 minus 2/3 plus 1/5 minus negative 1 plus 2/3 minus 5/3. All right, 1/5. Ooh. Am I right? You guys are not. That's what I get. Is that what you get when you plug them in?
Hold on. On the where it says 1 minus 2/3 plus 1/5, wouldn't that minus sign be a plus sign?
In the middle? Or
No,
here?
no, right there.
No, because when I plug in 1, it,
Oh, I was doing negative 1.
yeah, on this negative one, yeah, you have to put the top minus the bottom. Remember? So you guys get the same thing I did?
Mm-hmm.
So now I have to distribute the negative, right? So it makes this plus, minus, plus. So that would be 2 minus 2/3 plus 2/5. I was hoping some would zero out, weren't you? Now I have to get what?
Why didn't we just? Because if we have, like, I don't even know how to explain it.
Well, we have this, I was hoping some would zero out, but we have this negative here, don't we? That we have
I'm
to,
so confused on why you changed every single sign after that one. I just thought that
because you have to distribute the negative. Correct?
Okay, so then negative 2, like in the first equations.
Oh, this
so it
should be
says
4.
Negative 2/3.
This should be 4. I did the 5 right, but I didn't do the 4. Is that what you were getting at?
Yeah.
Okay, so now I have to get common denominators, right? So between 5 and 3, it's what?
Um,
15, isn't it?
yeah.
So the 2 becomes a 30 minus 20 plus 6.
Should be 16.
So it'd be 16. So 16 pi over 15.
Yeah.
And that's what they got too. Woo woo. Now, did they take a little while?
Yeah.
Yeah. We have more problems to do. If you want to get started on the assignment, but this, you do not have everything you need for the assignment.
Okay.
Got it?
Mm-hmm.
So the assignment is 7-2, page 465, 1 through 14. Now, 1 through 10, they have pictures. We didn't do any of the Y's, but is it really going to change anything?
Yeah.
A little bit, not a whole ton. But the first 6, actually, you do have enough to do the first 6. Okay? So I would like you to attempt those first 6. Can make a deal on that one.
I can try. I'm pretty busy today, so.
I believe in you.
I have work from 4 to 7:30, and then stage band practice from 7:30 to